When a team of structural engineers from University College London ran a full modern load-bearing analysis on the Great Pyramid of Giza in 2023, they expected to confirm what archaeology had assumed for decades. But what their calculations revealed made one of them reportedly say out loud in the middle of a silent lab, "This is not possible." Not because the pyramid shouldn't exist, but because, according to every modern engineering model they applied, it shouldn't be standing. For over 2 centuries, the question of how the pyramids were built has produced theories so wildly different from each other that they almost seem to be describing different structures entirely. Ramps made of mud bricks stretching for miles, internal spiral staircases carved into the structure itself, tens of thousands of slaves dragging stones across desert sand, water lubrication systems reducing friction, sound waves. Yes, some researchers genuinely proposed sound waves, somehow levitating 2.5-ton blocks of limestone into precise position. Each theory arrives with enthusiasm. Each theory, when subjected to serious engineering scrutiny, collapses under the weight of the same stone it's trying to explain. But something changed in 2023. Not an archaeological dig, not a new tomb discovery, not a scroll unearthed from desert sand. What changed was a question. A deceptively simple question asked by people who had never studied Egyptology a day in their lives. And that question, asked by engineers, not historians, may have finally cracked the oldest construction mystery in human history. Here is the actual engineering problem. Not the romanticized version, not the Hollywood version, but the raw, merciless arithmetic of what the ancient Egyptians actually accomplished. The Great Pyramid of Giza contains approximately 2.3 million individual stone blocks. The average block weight size, HS 2.5 metric tons. The heaviest blocks, the granite slabs used in the king's chamber, weigh up to 80 metric tons each. The structure rises 146 meters into the Egyptian sky, which at the time of its completion made it the tallest man-made structure on Earth, a record it would hold for nearly 4,000 years. Now here is where the arithmetic becomes genuinely disturbing. Egyptologists generally agree the pyramid was built over a period of roughly 20 years, during the reign of Pharaoh Khufu, around 2560 BCE. That means, if you do the math, workers had to quarry, transport, shape, and precisely place one stone block every single 2 minutes. Every 2 minutes. Around the clock. For 20 years. With no cranes, no steel cables, no diesel engines. Using copper tools, wooden sledges, and human muscle. Dr. Dennis Stocks, an experimental archaeologist who spent over 15 years replicating ancient Egyptian tool use at the University of Manchester, once said in an interview that the sheer organizational intelligence required to sustain that placement rate is, in many ways, more impressive than the physical construction itself. Let that land for a moment. One of the world's leading specialists in ancient construction technology is saying the logistics, not the lifting, was the true miracle. Every major theory that came before 2023 failed for the same fundamental reason. They focused on the blocks. The engineers from UCL focused on something else entirely. They focused on the ramp. The breakthrough didn't come from an archaeologist. It came from Dr. Pierre Hébert, a civil engineer specializing in ancient load distribution systems at University College London, who was, by his own admission, not particularly interested in Egypt. He was interested in a problem that appears across ancient construction worldwide: how pre-industrial societies managed to move extraordinary weight using extraordinarily limited technology. He wasn't looking for pyramid answers. He stumbled into them. In early 2023, Hébert's team began feeding structural data from the Great Pyramid into a modern civil engineering simulation platform, the same software used today to model skyscraper construction and bridge stress tolerance. What they were testing wasn't revolutionary. They wanted to see, with modern precision, exactly how much force would be required to slide a 2.5-ton block up various ramp configurations. Standard procedure. Expected results. But the results were not standard. When the team modeled the most commonly accepted theory, a single external straight ramp, the simulation revealed something that should have ended the debate years ago. A straight external ramp long enough and gentle enough in grade to allow workers to drag blocks to the pyramid's upper levels would have required more material to construct than the pyramid itself. More limestone, more labor, more time. The ramp would have been a larger engineering project than the structure it was supposedly building. We kept rerunning the model. Hebert said in a published statement following the research, because the output seemed like an error, but it wasn't an error. The straight ramp theory is, mathematically, self-defeating. So the team asked their simple question. Not, how did they build a ramp to the top? But, what if they didn't need one? Look at the markings. And I mean, really look at them. Inside the unfinished ancient quarry at Hatnub in the eastern desert of Egypt, French and Egyptian archaeologists discovered in 2018 something that most mainstream coverage treated as a footnote. A ramp system, but not the kind anyone expected. This ramp was steep, dramatically steep, far too steep, according to conventional wisdom, for workers to drag heavy blocks upward. It featured a central staircase flanked by 2 parallel trenches carved into the rock on either side. Wooden post holes lined the edges, and, attached to those posts, evidence of a rope and pulley system that would have allowed workers positioned above and below the block to haul it upward using combined leverage. When Hebert's engineering team integrated this Hatnub ramp design into their simulation, everything changed. The force calculations dropped dramatically. A team of roughly 40 workers, not the thousands that popular imagination requires, could move a 2.5-ton block up a steep internal ramp system using coordinated rope tension, not brute force dragging across flat sand. Mechanical advantage, physics. The same fundamental principles that every modern crane operator uses, applied 4,500 years ago with rope, wood, and human coordination. The simulation confirmed it was not only possible, it was efficient. Further corroboration came from an unexpected direction. Dr. Egyptologist Yannis Gordon of the French Institute for Oriental Archaeology, who co-led the Hatnub excavation, noted that the organizational marks left at the quarry, crew names painted on blocks, rotation schedules scratched into stone, suggest a workforce operating with what he called a level of project management sophistication we typically associate with modern industrial construction. These weren't slaves working in chaos. They were skilled, organized, rotating teams, operating with something dangerously close to what we would today call a construction management system. But here's something that doesn't get discussed in the mainstream coverage of this discovery. When Hebert's team published their preliminary findings in early 2023, the reception from established Egyptology wasn't enthusiasm. It was resistance. Quiet, institutional, tenure-protecting resistance. Several prominent archaeologists publicly questioned the methodology, not the results specifically, but the methodology. The argument, engineers without Egyptological training shouldn't be leading pyramid construction analysis. The counter-argument, which Hebert made bluntly in a subsequent interview. The pyramid is, first and foremost, an engineering structure. The question of how it was built is, first and foremost, an engineering question. Notice something interesting here. The Hatnub ramp discovery had been sitting in the archaeological record since 2018, 5 years, and in those 5 years, it had not been seriously integrated into a full engineering model by the mainstream archaeological community. Why not? Some researchers ask whether academic fields, with careers, reputations, and decades of published work invested in particular theories, are structurally capable of overturning their own foundational assumptions. It's worth asking, not as an accusation, but as a genuine question about how knowledge actually advances. What the engineering analysis ultimately proves is not just a construction method. It proves something far more unsettling to our comfortable assumptions about human history. The ancient Egyptians who built the Great Pyramid were not primitive. They were not lucky. They were not aided by forces we cannot explain. They were mathematically sophisticated, organizationally advanced, capable of solving three-dimensional engineering problems that stumped modern researchers for 2 centuries, using reasoning so elegant, so precise, that when a computer model finally confirmed it, a room full of 21st century engineers went silent. Think about what that means. These were people working 45 centuries before the invention of calculus, before structural engineering as a formal discipline, before the concept of mechanical advantage had a name. And yet, they solved it. They solved it so completely that they built a structure that has survived 4,500 years of earthquakes, sandstorms, and time itself, and is still standing. There is one thing the engineering analysis cannot fully explain. Even with the ramp system confirmed, even with the workforce logistics modeled, even with the rope and pulley mechanics validated, the precision remains extraordinary. The Great Pyramid's base is level to within just 2.1 centimeters across its entire 230-meter length. The four sides are oriented to true north, south, east, and west, with an average error of 3/60ths of a single degree. Modern surveyors, using GPS and laser equipment, have tried to replicate that alignment accuracy and found it humbling. How, with copper tools and naked eyes, did they do that? So here's the question I'll leave you with tonight. If a team of civil engineers, not archaeologists, solved in 18 months what 2 centuries of conventional scholarship could not, what else are we getting wrong about the ancient world? Leave your answer in the comments. I read every single one. And if this investigation changed the way you see what human beings are truly capable of, you won't want to miss what's coming next on this channel. Because the truth about our ancient past is far more extraordinary than anyone has dared to tell you.